So let us take one binary example with only two words in the category. Okay. So let's say I have 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1. Let me see the same example. 12, 8, 9, 18. 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0. Yeah. Okay, so let's see how we do this encoding. Okay, so we start with assume both a sender and receiver have 0 and 1 in the vocabulary. Okay, it's very interesting. What it does is it starts looking at the unencoded part, just like we saw the previous example. Binary is a little bit more easy to understand. So what we do is, so we have, let me draw these blocks. So we have the, we see the final representation that goes on. Okay? So let's say position in the code book. So I have in position 1 this code book. Position 1 and 2 I have. So receiver and sender have this. Now this is still not processed. So what's the longest substring that I have using the words in the dictionary? I have 0, 0. So I add 0, 0 to the dictionary. Next, what do I have? This is over now. I've already passed this. Next is 0, 1, not seen, not there in the dictionary. So longest prefix that I say. Then next, what do I see? So this is passed. This is what is the longest prefix that's not there in the dictionary? 0, 1. Now next, what do I see? I've not seen 1, 0. None of these examples have 1, 0. So I add 1, 0 to the dictionary. Now I'm here now. I add, I've not seen 0, 1 is there. I've not seen 0, 1 is there. I add to this. Then what do I see? 1, 0 is there. So I add to the position 1, 0, 0. Then I come here. This is done. This is done. So I come to the 9th position. I put 1, 0. How is this encoded? We will see. So when we are sending it out, for example, we're going to send 0, 0. Now what is this now? This is actually the code for this should be, this is actually the symbol. If you look at the numeric representation of this, so it will be something like this. Okay, let's say I'm using 4 bits. Then what's the first symbol that we're seeing? We're seeing this plus a 1, right? So this is like 1, 1. If I look at this location up here, and this is, sorry, not this, 0, 0, right? This is 1, 1. This is 1, 2. And this is 4, 2. And this is 2, 1. And this one is 4 and 1. And this is 6 and 1. And 6 and 2. So this is what we need to transmit. So what we do is, we say this is 0, 0, 1 followed by 1. I'm sorry, 0, 0, 1 followed by 0. This symbol, this, and this is what? 0, 0, 1 followed by 1. And this is what? This is 4, right? 4 is 1, 0, 0 followed by 2, which is the symbol 1. This is 2, 1 Therefore, this is 2 1 should be 2 1. Sorry, 2 1, right? What is 2 now? 0 1 0 followed by 0, and this is 0 1. This is 1 0 0 followed by 0, and this is 1 0. Where is 1 0 now? 6, no? So 1 1 0 followed by 0, and this is 1 1 0 followed by 1. So what do you do when you pass this entire string? You send the code 0010 for 00. For 01 you send 0011, and for 1011, for 011 you will send 1011, 1001, and for 10 you will send 0100, and for 010 you will send 1000, and for 100 you will send 1100, and 1101 for this. So how does it work? By decoding. Let's see how we decode. What do we do? We only have 1 and 0 in vocabulary. So what it does is it looks at this and keeps on building. So it'll take the 4 bits. It's a fixed length code. So it chunks 4 bits at a time, takes a 001 and a 0 separately. So what is there in the first position? 0. Therefore, the decoded string is 0. Then it sees 001, 1. So what is it? First position is again 0 and followed by 1, and so on. 100 now, and then it keeps building because it's seeing this, right? Next, what is it seeing? It is seeing 10, 100 and 1. So that means what the last one is. Next, what did we see? 011 takes at 4 and 2. 4 is already there. So you build the 4 into the, so you put the, you as soon as you see these symbols, you fill the dictionary at the receiver. At the receiver. Okay, that's exactly what it's doing. So how does it do it? It saw, let me go through this again. So it saw 00, right? So it knows that this one has to be added to dictionary. Then it saw, take the first 3 bits and the 1, add it to the dictionary. Okay, so where do these come? These come at 3 and 4, and this is 4 and 1. So therefore, it has to be 0, 1, 1. This is how it goes. Okay, so what is interesting is about this Lempelzib algorithm, it's very easy to write, and it depends on repeated patterns, and compared to Huffman coding, Huffman does not require prior knowledge, but prior information. Okay, but it looks for repeated patterns. So all the time notice that if there is a pattern that is there, it's looking for the longest prefix plus a new character in the input stream to build the codebook. So the receiver also builds the codebook on its own. Okay, and then decodes. So this is the thing about this coding algorithm. Let me stop here.